What if the universe you're living in right now isn't what it seems at all? What if everything you touch, see, and even think is part of a grand illusion, a fragile story held together by forces so strange that even the brightest minds on Earth can't fully explain them? For as long as we've existed, humans have asked the same question in different forms: where did everything come from? The common answer is the Big Bang, a violent eruption of energy that sparked time, space, and matter into existence about 30. But here's the problem. The more scientists dig into that moment, the less sense it makes. Because if the universe had a beginning, then what came before it? And if nothing existed, how can something explode out of absolute nothingness? That simple question shatters everything we think we know about reality. Think about it. Before the Big Bang, there was no ticking clock, no place to stand, not even the possibility of asking what happened. Time itself didn't exist. Asking what came before is like asking what's north of the North Pole. The very language we use falls apart, and yet physics keeps whispering something disturbing. Maybe nothing was never truly nothing. Maybe the emptiness we imagine as a blank void was actually boiling with energy, particles flashing in and out of existence like sparks on a dark night. If so, then the Big Bang might not have been the beginning of everything. It could have been just one event in a far stranger and much larger story. And here's where it gets unsettling. If one universe can burst into existence out of nowhere, why wouldn't there be countless others? Why would the cosmos stop at just one? The thought leads to questions that sound like science fiction but are backed by the sharpest mathematics we have. Infinite universes, infinite realities, and possibly infinite versions of you. And if that doesn't shake the ground beneath your feet, the truth hiding deeper in the equations will. The story of our universe's beginning is both the most widely accepted idea in science and at the same time one of the most confusing puzzles ever imagined. We've been told that everything we know, every galaxy stretching across the night sky, every star burning for billions of years, and every atom inside your body all came from a single moment, the Big Bang. It sounds simple when you first hear it. The universe exploded into existence and kept expanding until it became what we see today. But the deeper you look, the stranger it becomes, because what scientists mean by Big Bang isn't really an explosion in the normal sense. It wasn't something that blew up inside an empty space like fireworks. It was the creation of space itself. Space, time, energy, matter, all of it burst into being in an instant. Imagine every speck of reality compressed into something smaller than a grain of sand, so small it had no width, no height, no depth. And then suddenly it erupted, stretching into a vast cosmos. That is the story written into the equations of physics. Yet there's a problem so massive that it makes the Big Bang look less like an answer and more like the start of an even bigger mystery. The problem is this: if the universe had a beginning, what came before it? We're used to thinking in terms of cause and effect. If something happens, it must have a reason. A spark causes a fire, a seed causes a tree, a birth causes a life. But when we trace back the universe itself, the chain of causes slams into a wall. At the beginning, there wasn't supposed to be time for anything to happen in the first place. No before, no sequence, no cause that we can identify. It's as if reality itself just appeared out of nowhere. This shakes the very foundation of logic, because nothing in our daily lives works that way. You never see a brand new car appear in your driveway without someone building it. You never watch a skyscraper materialize from thin air. And yet, the greatest structure of them all, the universe itself, seems to have done exactly that. The human brain, designed to understand patterns in a world of causes, refuses to accept it without a fight. That's why, from the earliest philosophers to the most advanced cosmologists, the question has been repeated in endless forms: how do you get something from nothing? But here's where the story takes a turn. The nothing that scientists talk about may not be the same nothing we imagine. We like to think of nothingness as a perfect void, an empty stage with no actors, no props, no audience. A place where absolutely nothing exists. But in physics, when you strip everything away, matter, energy, even light itself, what you're left with is far stranger. Empty space isn't empty at all. On the smallest scales, it trembles with activity, a restless ocean of particles that flicker into existence for a fraction of a second before vanishing again. This quantum foam, as it's often called, is the restless heartbeat of the cosmos itself, and it means that the void we imagine as silent and dead is actually buzzing with energy. If that's true, then the Big Bang might not have been a magical moment of creation from absolutely nothing. Instead, it could have been a ripple in this ocean of quantum possibilities. Imagine a storm forming in a calm sky, or a bubble suddenly appearing in boiling water. One fluctuation among countless fluctuations just happened to expand instead of collapsing. That tiny bubble inflated into the universe we now see. To put it another way, the universe might have been a random accident, not the kind of accident that happens once, but the kind of accident that happens infinitely over and over again until one of them grows into something like this. And this is where the mystery only deepens. Because if a universe can spring into being from a fluctuation in quantum nothingness, what's to stop more universes from doing the same? Why would there only be one? Suddenly, the Big Bang doesn't look like the unique event we've always imagined. Instead, it looks like the opening scene of a much larger play, one in which our universe is just one bubble floating in a cosmic sea of countless others. Some may be empty and sterile, dying before they can form stars. Others may be wildly different, filled with bizarre laws of physics that make them unrecognizable. And some might look eerily similar to ours, with galaxies, planets, and maybe even versions of life that feel like distorted reflections in a mirror. Now, take a step back and consider how radical this idea is. For centuries, humans assumed Earth was the center of everything. Then we discovered the sun was the center of the solar system, not us. Later, we learned our sun was just one star among billions in the galaxy. Then we discovered that our galaxy itself was only one of trillions scattered across the cosmos. Each time we've looked deeper, we've realized we're smaller than we thought. The possibility of multiple universes takes that same humbling trend and pushes it to the extreme. Not only are we not the center of the universe, we might not even live in the only universe. We might be just one of infinite realities, a single possibility in an endless lottery. But there's something even more disturbing about the Big Bang, something that scientists struggle to put into words. When we talk about an explosion, we picture something happening inside space. Fireworks burst in the night sky, and the explosion fills the air. The star collapses, and the blast spreads across the galaxy. But the Big Bang didn't happen inside space. It was the creation of space. Space itself stretched from a point smaller than imagination, expanding faster than light, dragging matter and energy with it. That's why asking where did it happen makes no sense. There was no outside for it to explode into. The universe didn't expand into space. The expansion created space as it went. It's as if reality unfolded from a single point, writing its own stage as the performance began. The more we pull on this thread, the stranger it gets. Because if space and time themselves were created in that moment, then the very concepts we use to make sense of beginnings and endings are useless. Talking about before the Big Bang is like trying to walk north from the North Pole. The direction itself loses meaning. Yet humans can't help asking the question, because we're wired to want a cause. We want to know what sparked the spark, and some scientists believe that hidden in the equations of quantum physics might be the answer, though it's not one that brings comfort. It suggests that maybe the universe didn't need a cause in the first place. Maybe the laws of physics themselves guarantee that universes will appear, disappear, and reappear forever, like waves rising and crashing on an infinite sea. Think about what that means for a moment. If the universe doesn't need a cause, if it can simply appear because that's what the rules of existence allow, then the very idea of why might be meaningless. Asking why the universe exists might be like asking why water is wet. It simply is. But if that's the case, then it also means that our universe is not unique. It's not special. It's just one of the countless inevitable results of the rules of reality playing themselves out. And buried in that idea is both something terrifying and something liberating. Terrifying because it makes us small, a random accident in a cosmic lottery. Liberating because it means the story is far from over. If universes can be born, then others can follow. If universes can appear, maybe they can vanish just as sudden. And if our universe is temporary, then the question becomes not why are we here, but how long will this fragile reality last? This is the paradox at the heart of the Big Bang. It explains everything and nothing at once. It gives us a starting point but refuses to tell us what came before. It suggests a law but leaves us with mystery. Maybe that's the most unsettling truth of all. that our existence, the total sum of stars and galaxies of life and death, of consciousness itself, rests on an event that we can't fully explain and may never be able to. An event that shattered nothing into everything and left behind a universe that is still expanding, still changing, and still filled with secrets we have only begun to uncover. When people hear about the Big Bang, they often imagine it as a fiery explosion that simply happened in an empty void, like a firework bursting in a dark sky. But the deeper you dive into the science, the stranger it becomes, because there wasn't even a dark sky to explode into. There was no emptiness waiting, there was no canvas ready to be painted. Time itself had not yet begun ticking. And here is where our minds start to break down, because everything in our daily experience is tied to the flow of time. We wake up, we grow older, we remember yesterday, we expect tomorrow. Without time, there is no sequence, no cause and effect, no before or after. The moment we try to imagine before the Big Bang, we are already falling into a trap, because the very word before relies on time existing, and time itself was born in that instant. It's almost impossible to think about. If you look at a clock and watch the second hand tick forward, you know that a moment just passed. But now picture a universe where the clock itself never existed until suddenly it appeared with that first tick. Time wasn't running in the background, waiting for the Big Bang to occur. The Big Bang didn't happen at a particular point in time, it brought time with it. Asking what came before is like asking what's north of the North Pole. It's not that there isn't an answer, it's that the question itself collapses. And yet, even when scientists explain this, the human brain refuses to let go of the question, because we are so deeply wired to think in terms of beginnings. Something must have triggered this. Something must have existed before. Surely there must have been a spark. This paradox drives some of the most fascinating debates in science. If time itself began with the universe, then does that mean the universe is eternal? Does it mean that outside of our reality, the very notion of time doesn't exist at all? If so, then what we call eternity is just the absence of time, not an endless stretch of it. Imagine floating in a state where there is no yesterday and no tomorrow, no waiting, no aging, no movement from one moment to the next. That was the state before the Big Bang, if you can even call it a state. And yet, somehow, from this timeless void, everything emerged. To understand this better, physicists sometimes turn to the mathematics of relativity. Einstein showed us that time is not a fixed backdrop, but something woven together with space itself, forming a fabric called space-time. Gravity bends this fabric, slowing down or speeding up the passage of time, depending on how massive an object is. To us, time feels absolute, but in reality it's elastic, stretching and warping with the universe. Now push this idea to its extreme. If time and space are inseparable, then the moment space came into existence, time was born alongside it. There was no pre-existing container of seconds and minutes waiting around. The Big Bang wasn't just the birth of matter and energy. It was the birth of the very stage on which reality unfolds. And this leads us into one of the most mind-bending ideas of all. Maybe the question of before the Big Bang isn't just meaningless, but maybe the universe didn't even need a before. Maybe it was always a closed loop. Some cosmologists suggest that time itself might be cyclical, not linear. Picture a circle instead of a straight line. In this view, what we call the beginning of the universe could also be the end, and vice versa. The universe may not have a start at all, just an eternal cycle of expansion and contraction, endlessly repeating. To us, this sounds almost mystical, but it's rooted in real physics. Equations describing certain models of the universe don't have a sharp starting point. They bend around like a loop, with no edge to fall off. But others push the mystery further, suggesting that time as we experience it might be an illusion altogether. Think about this. The universe at its deepest level may not be made of things or matter, but of information. And information doesn't need to flow like time does. Past, present, and future could all exist simultaneously, like pages of a book. When you read a story, you experience it one page at a time, moving from beginning to end. But the entire story already exists in the book, whether you've read the last page or not. In the same way, our experience of time might be nothing more than moving through a story that is already written, while in the higher reality beyond us, all moments simply coexist. The Big Bang, in that case, wouldn't be a start in the way we imagine it. It would just be one page in the grand narrative of existence. This is why some physicists argue that time is emergent. It's not fundamental, but something that rises out of deeper law. Much like temperature doesn't exist in a single molecule. You need a collection of molecules moving together to have heat. Time may not exist at the most basic level of reality. It may only appear when certain conditions are met, like consciousness observing the world, or particles interacting in large numbers. If that's true, then before the universe reached the scale we see today, there may have been no time at all, only raw potential waiting to be realized. The implications are staggering. It means the moment we think of as the ultimate beginning may not be unique. There could have been countless births of time, countless moments where the void flickered into a new reality. Some might have collapsed instantly, never lasting long enough to create stars. Others may have spread outward like ours, giving rise to galaxies and eventually to life. And if this process is eternal in a way beyond our comprehension, then universes could be popping into existence endlessly, without a single first moment to point to. And yet, even as the science advances, there's still something deeply unsettling about this idea. Human beings crave certainty. We want to trace the story back to a first cause, a first mover, a first reason. We want to know why the spark lit in the first place, but the universe seems to be telling us that there may be no such answer. The very laws of physics may allow for existence to simply be, without a trigger. That doesn't mean we'll stop searching. In fact, the hunger for answers only grows stronger, because if we can't explain why there was a first moment, maybe the key lies in looking not backward but deeper into the fabric of space-time, deeper into the quantum fluctuations beneath reality, deeper into the possibility that our entire experience of time is just a shadow cast by something larger, stranger, and more fundamental. When you really think about it, this is what makes the universe so unnerving. Not that it began, but that it continues to exist at all. Not that time had a first tick, but that it keeps ticking, that it carries us forward without pause, dragging everything from stars to atoms along with it. And maybe one day we'll find that the flow of time, the very thing we depend on to measure our lives, is only a temporary feature, a local illusion in a much grander reality. If that's the case, then our obsession with beginnings is misplaced. The true mystery is not what came before, but why anything came at all, and why we are here inside this particular page of the cosmic book, reading the story unfold. When you strip the universe down to its most basic ingredients, you might expect silence. No stars, no galaxies, not even atoms, just pure emptiness. But emptiness, it turns out, is an illusion. The closer you look, the more alive it becomes. On the tiniest scales, far smaller than anything we can directly see, space itself shivers with energy. Particles flicker into existence for a fleeting instant, then vanish before they can be noticed. This restless sea, known as quantum foam, is the strange reality hidden beneath what we call nothing. And it's from this jittering void that some scientists believe the entire universe may have been born. To make sense of this, imagine staring at a calm pond. On the surface, the water looks still and quiet, but beneath, molecules are bouncing chaotically, colliding, vibrating, moving faster than your eyes could ever track. Quantum foam is like that hidden turbulence, but infinitely stranger. According to quantum theory, the vacuum of space isn't empty. It's full of fluctuations, tiny bursts of energy that appear out of nowhere. For a moment, a particle and its mirror image, an antiparticle, spring into being, borrowing energy from the vacuum. Then, just as quickly, they annihilate each other and vanish, repaying the debt. This borrowing happens so fast that it doesn't break any physical laws. In fact, it's allowed, even required, by the mathematics of quantum mechanics. What we see as empty space is actually a constant storm of creation and destruction, a seething chaos invisible to us but fundamental to reality. Now, here's where it gets truly mind-bending. If these fluctuations are happening all the time, endlessly, then perhaps one of them didn't vanish. Perhaps one fluctuation, against impossible odds, inflated instead of collapsing. Imagine a bubble forming in boiling water. Most bubbles pop instantly, but once in a while, one grows larger, detaches, and rises to the surface. In the same way, a single fluctuation in the quantum vacuum may have expanded, stretching faster than light in a moment of runaway growth, becoming the universe we now inhabit. In that sense, the Big Bang wasn't the birth of everything from nothing. but the survival of one bubble in an infinite cosmic storm. This idea is unsettling because it means our existence could be nothing more than the result of chance, a random fluctuation that worked while others fizzled out. Think about that for a moment. If space itself is bubbling with energy, then new universes might be sprouting constantly, each born from a quantum hiccup, most collapsing before they matter, some stretching into endless realities. That would mean the multiverse isn't just possible, it's inevitable. Infinite bubbles, infinite universes, infinite possibilities. Our universe, with its stars and galaxies and life, is simply one lucky bubble that didn't pop. To get a sense of the scale here, picture this. Every second, billions upon billions of these virtual particles are blinking in and out around you. They are everywhere, weaving themselves into the very fabric of the cosmos. You don't see them, but their effects are measurable. They help explain why atoms behave the way they do. They influence the energy of space itself. They even contribute to forces we can observe in experiments. Proof that this invisible storm is real. So when cosmologists say the universe may have sprung from quantum foam, they're not speaking metaphorically. They're pointing at the wild energy of reality's foundation, an energy so strange that it refuses to stay still. And yet, this explanation opens more questions than it answers. If the universe is the result of a fluctuation, why did it inflate into something so vast? What caused it to grow instead of vanish like all the others? The theory of cosmic inflation suggests that certain conditions allowed this tiny fluctuation to balloon at unimaginable speed, doubling in size again and again in a fraction of a second, until it became the universe we see today. But why did those conditions exist at all? Why did this bubble survive? And if the laws of physics make fluctuations inevitable, does that mean there's an endless number of universes being born right now, in places we can never reach? Here's where the imagination strains. If infinite universes exist, then every possible version of reality could be real somewhere. A universe where stars never formed. A universe where gravity is so strong that life could never evolve. A universe where stars never formed. A universe where gravity is so strong that life could never evolve. The idea is staggering, and for many people deeply unsettling. But there's another layer to this. If the universe came from a quantum fluctuation, then reality itself is tied to probabilities. Quantum physics doesn't deal in certainties. It deals in chances. A particle isn't in one place or another until it's observed. It's in many possible places at once. A cloud of probabilities. If our universe is a product of quantum chance, then existence itself may be fundamentally uncertain. The solid ground beneath your feet, the stars above your head, even the flow of time, all of it rests on the same shaky foundation, an ocean of probabilities where nothing is guaranteed. Think about how strange that is. Every breath you take, every beat of your heart, every moment of your life depends on the survival of a bubble that might easily never have existed. One random fluctuation among endless others expanded into a reality that includes you. It's almost as if existence itself is the ultimate lottery, and somehow, against all odds, we're holding the winning ticket. But instead of making us feel special, this truth can make us feel small. Because if universes can emerge endlessly from the foam, then ours isn't unique. It's one of countless outcomes. Nothing about it was destined. Nothing about it was guaranteed. And yet, buried in that thought is something almost poetic. If universes are born from chaos, then life itself, fragile, fleeting, improbable, is the spark of meaning inside the storm. The fact that we are here, aware enough to ask these questions, is extraordinary. In a sea of fluctuations, where most bubbles vanish without leaving a trace, we're part of one that lasted long enough to produce minds capable of wondering where it all came from. That awareness is itself another kind of fluctuation, one that may vanish as quickly as it appeared, but for now, it is real. This is why some scientists whisper about the possibility that the universe is self-creating, that existence doesn't need an outside cause. The rules of quantum mechanics may guarantee that something will always emerge from the foam. In that case, nothingness is impossible. True emptiness doesn't exist. There will always be fluctuations. There will always be new bubbles. And somewhere, always, there will be new universes being born. Our cosmos, then, isn't the exception. It's the rule. The only reason it feels unique to us is because we happen to be inside it. From the outside, it may be just another ripple in the endless sea. And here's the twist that keeps physicists awake at night. If universes are constantly appearing and disappearing, how do we know ours will last? What if our entire existence is only temporary, a fluctuation that will one day collapse? Returning to the foe, cosmology suggests that our universe is expanding faster and faster, driven by a mysterious dark energy, but no one knows how long that expansion will continue, or what it truly means. For all we know, the same chaos that gave birth to our universe could one day unmake it. The same fluctuations that created the spark could extinguish it, and there would be nothing anyone could do. It's a sobering thought, but also a thrilling one, because it means reality itself is alive, restless, never still. The universe is not a static stage where the play of existence unfolds. It is the play, it is the storm, and somewhere in that storm, in one tiny fragile bubble, consciousness has appeared, asking questions about its own origins. That, perhaps, is the greatest mystery of all, that from the chaos of fluctuations, not only did matter and energy arise, but so did awareness, the ability to look back at the storm and wonder why it happened. The Big Bang may have set everything in motion, but it left behind puzzles that refused to go away. When scientists look at the universe, they notice something strange. No matter where you point a telescope, in every direction, space looks almost the same. The temperature of the cosmic background radiation, the faint glow left over from the universe's earliest moments, is nearly identical everywhere. That might not sound shocking at first, but think about what it means. Regions of the universe separated by billions of light years are practically twins, even though they've never had enough time to interact. Light itself hasn't had enough time to travel from one side to the other since the Big Bang, and yet they're in perfect sync. This mystery is called the horizon problem, and it raises a serious question. How can the universe be so uniform when its parts should never have talked to each other? Another riddle is just as troubling. The universe looks flat. Not flat like a pancake, but flat in the sense that its geometry balances on a razor's edge. If the universe had been slightly more curved at the start, gravity would have pulled everything back into a quick collapse. If it had been slightly less curved, everything would have flown apart so fast that galaxies and stars would never have formed. Yet somehow our universe landed in the sweet spot. It's expanding, but not too fast. It's stable, but not too fragile. The odds of hitting this balance by chance are almost unimaginably small, and yet here we are, sitting in the middle of that delicate equilibrium. For decades, these puzzles haunted cosmology. Then, in the early 1980s, a radical idea surfaced. Maybe right after the Big Bang, the universe went through a brief but staggering phase of inflation, expanding faster than the speed of light for a fraction of a second. In that blink, everything ballooned outward so quickly that tiny regions of space were stretched beyond comprehension, smoothing out irregularities and explaining why distant parts of the cosmos look identical today. Inflation solved the horizon problem by suggesting that those distant regions were once close together, before the expansion pulled them apart faster than light could keep them connected. It also explained the flatness problem, because the rapid stretching would have flattened any curve, just as blowing up a balloon makes a small patch look flat to the eye. But inflation didn't just solve problems, it opened the door to ideas more unsettling than anything before. If the universe inflated once, what's to stop it from happening again? Some versions of the theory suggest inflation is eternal, but it never completely stops. Instead, pockets of space keep ballooning endlessly, each pocket forming a new universe when inflation ends inside it. That would mean our universe is only one bubble in an infinite foam of universes, each born from runaway inflation. It's an image that turns everything upside down. The Big Bang wasn't the unique birth of reality. It was just one spark among countless others in a cosmic fireworks show that never ends. Picture this. You're standing on the shore of an endless ocean, and bubbles are rising all around you. Each bubble is a universe, with its own space, its own time, its own laws of physics. Some might expand quickly and die out. Others might last trillions of years. Some might contain galaxies and life. Others might be barren voids. From the outside, they're just bubbles in the foam. From the inside, each feels infinite, just as ours does. Inflation suggests that this bubbling process is happening eternally, beyond our reach, beyond our comprehension. And if that's true, then the question isn't why the universe exists. It's why we find ourselves inside this particular bubble instead of another. What makes this even stranger is that inflation doesn't just explain smoothness and flatness. It also predicts the tiny seeds of structure that would eventually grow into galaxies and stars. During inflation, quantum fluctuations, those random jitters in space itself, were stretched to cosmic scales. Some regions became slightly denser than others, and over billions of years, gravity amplified those small differences into clusters of galaxies and vast cosmic webs. In other words, the stars we see, the planets we live on, even the life that evolved here, all trace their origins back to quantum noise stretched across the sky by inflation. The universe as we know it may be nothing more than ripples of randomness, magnified into grand pattern. It's hard to wrap your mind around. The same mechanism that explains why the universe is so uniform also explains why it isn't perfectly uniform. Without those tiny irregularities, everything would have spread out evenly, and no galaxies would have formed. We would never have existed. Inflation gave us both smoothness and just enough imperfection to spark structure. Too much irregularity, and the universe would be chaotic. Too little, and it would be sterile. Instead, we landed on the knife's edge once again, and that balance makes some wonder if the universe is fine-tuned, or if in an infinite multiverse it was inevitable that some bubble would stumble into just the right condition. But here's the haunting part. If inflation is real, then our universe may be forever isolated. We can never see beyond our own bubble, because the space between bubbles is still inflating faster than light. Even if other universes are right next door, we'll never reach them. They're locked away, cut off by endless expansion. The only evidence we might ever glimpse is a faint scar in the cosmic microwave background, the subtle imprint left behind if our bubble ever collided with another. Some scientists have searched for these marks, tiny distortions in the ancient light that fills the universe. So far, the evidence is uncertain, but the possibility lingers. Somewhere, hidden in the static of the sky, could be the fingerprint of another universe brushing against ours. And yet, inflation itself is still controversial. Not everyone agrees it's the final answer. Some physicists argue it's too convenient, that it solves mysteries by introducing an even bigger mystery. What caused inflation in the first place? What made space suddenly expand so violently, then stop? The mechanism remains elusive, hidden in the mathematics of hypothetical fields we've never detected. And if inflation is eternal, spawning infinite universes, it may be impossible to test fully. We can only see our bubble, never the other. That leaves us in a strange place, torn between a theory that elegantly explains what we observe and the realization that it may always remain beyond proof. Still, the allure of inflation is powerful because it reframes everything we know. It suggests the universe is not a singular miracle, but part of a vast eternal process. It means the Big Bang wasn't the absolute beginning, but just one chapter in an infinite book of universes. And if that's true, then reality is far stranger than anything our ancestors ever dreamed. The night sky, dotted with stars, may only hint at the true scale of existence. Beyond what we see, beyond what we can ever measure, there may be endless other skies, other galaxies, other beings asking the same questions we are. Inflation forces us to confront an unsettling possibility that our universe is not special, that it was not chosen, that it is not even rare. It's simply one of countless outcomes in an eternal process of creation. And yet, paradoxically, it also makes our existence feel miraculous, because in the storm of universes, in the endless bubbling sea, we ended up in one where galaxies form, stars burn, planets emerge, and life asks why it's here. The odds may be infinite, but the fact remains, we are here, inside this bubble, gazing outward, wondering what lies beyond. And maybe that's the ultimate lesson of inflation. The answers we find don't make the universe less mysterious. They only deepen the mystery, pulling back the curtain to reveal another stage, larger and stranger than we imagined. We thought the Big Bang was the beginning, but now it seems more like a doorway, opening onto an endless expanse of realities. The question is no longer what caused the universe, but how many times has it happened before, and how many times will it happen again? And the most chilling thought of all is this: if inflation never ends, then somewhere right now, another universe is being born, racing outward faster than light, beginning its own story. And in that universe, another version of this question may already be forming, whispered by minds that don't yet know they exist. More scientists explore the idea of cosmic inflation, the harder it becomes to escape a startling conclusion. If inflation really happened, it probably didn't just happen once. It may be happening endlessly, spawning universe after universe in an eternal chain of creation. This leads to one of the most fascinating and controversial concepts in modern science, the multiverse. It's an idea that takes the vastness of our universe and multiplies it beyond imagination. Instead of one cosmos containing everything, reality may be a boundless ocean of universes, each a bubble floating in an infinite sea. And if that's true, then everything we think of as ultimate, the galaxies, the stars, the laws of physics themselves, might be just one small variation in an endless cosmic lottery. At first, the multiverse sounds like pure fantasy. After all, how can there be more than one universe when the very word universe is supposed to mean everything? But in physics, the term has become flexible. Our universe is everything we can see and measure, everything within our cosmic horizon. Beyond that, there could be regions of space so far away that we'll never reach them, regions forever cut off by the expansion of space. Those regions could be called other universes, and inflation suggests there may be an infinite number of them, each sealed away in its own bubble of space-time. Now, here's where it gets even stranger. Each universe may not just be a carbon copy of ours. They might follow different rules entirely. The laws of physics we take for granted, the strength of gravity, the speed of light, the behavior of atoms, might be different in another bubble. One universe might collapse instantly under crushing gravity. Another might expand so quickly that stars never form. Another might be filled with bizarre particles that make life impossible. And yet, somewhere in that endless variety, universes will exist with conditions just right for life, just right for consciousness, just right for you sitting here wondering if there are other yous doing the same thing in a parallel reality. Think about the implications. If there are infinite universes, then everything that can happen not only might happen, it must happen. Somewhere there's a universe where you never existed at all. Somewhere else there's a universe where history played out differently, wars ended sooner, civilizations rose and fell in different patterns. Entire species lived or died based on tiny changes. And in another there could be a version of you who made one small choice differently, and that choice changed everything. A job you didn't take here, a word you didn't say, a path you didn't walk. In another universe, that alternate choice was real, and your life followed a completely different arc. The thought is both thrilling and deeply unsettling, but the multiverse isn't just wild speculation. It's a natural consequence of the physics we already know. Inflation almost demands it. If space can inflate once, there's no reason it wouldn't inflate again, and again in countless regions. Quantum mechanics also hints at parallel realities through the many worlds interpretation, which suggests that every possible outcome of a quantum event actually happens, creating branching universes with every decision. Combine these ideas, and you don't just get a few universes, you get an infinite fractal of realities, branching endlessly in ways we can't even fully imagine. To make this less abstract, picture the universe you know as one bubble drifting in an ocean. That bubble contains everything we can see, every galaxy, every star, every atom. Now picture countless other bubbles, some larger, some smaller, some so alien that they would look unrecognizable. The ocean itself is inflation, endlessly producing more bubbles. We live inside one, but there is no reason to think it is special. To us it feels infinite, but from a higher view it's just one among countless others, floating alongside them, never touching, never merging, each sealed away in its own space-time. And yet some theories suggest collisions might happen. Just as soap bubbles can bump into each other, universes might occasionally brush against their neighbors. If that happened, the aftermath could leave scars, strange patterns in the cosmic microwave background, subtle imprints of a collision written into the oldest light of our universe. Scientists have looked for these signatures, searching for clues that we might not be alone. So far, the evidence is inconclusive, but the possibility remains tantalizing. Imagine looking up at the night sky and realizing that the faint irregularities in its glow are not random, but the bruises of another universe slamming into ours long before stars were born. The idea of the multiverse also reframes one of the biggest mysteries in science. Why does our universe seem so perfectly tuned for life? The laws of physics are balanced with extraordinary precision. If the strength of gravity were even slightly different, stars would never ignite. If the electromagnetic force were weaker or stronger, atoms might not hold together. If dark energy were a little larger, the universe would have torn itself apart before galaxies could form. The odds of everything lining up just right seem impossibly small. Some see this as evidence of design, a hint of purpose behind the cosmos. But the multiverse offers another explanation. If infinite universes exist, then all possible combinations of physical laws exist somewhere. Most universes are sterile, most are barren, but inevitably some will land on the right conditions for life. We live in one of those simply because we couldn't exist in the others. It's not that the universe was made for us, it's that we found ourselves in the universe where life was possible, because only in such a universe could we be asking the question. This explanation is elegant, but also unsettling. It strips away any sense of cosmic specialness. Our universe may not be finely tuned by intention, but by inevitability, the byproduct of a vast multiverse where all possibilities are realized. That makes us feel both smaller and larger at the same time. Smaller because we are just one possibility among infinite others. Larger because it suggests the story of existence is far grander than anything we imagine. A multiverse is not just a scientific theory, it's a radical shift in perspective. It means the ultimate horizon is not the edge of our universe, but the endless ocean beyond it. An ocean we may never touch, but that might contain answers to questions we can't stop asking. And here's the strangest part of all. If the multiverse is real, it might already have influenced us in ways we don't realize. Some cosmologists speculate that the unexplained anomalies in the cosmic background radiation could be faint echoes of neighboring universes pressing against ours. Others wonder if the flow of dark energy, the mysterious force accelerating our expansion, could be shaped by interactions with universes we can't see. These ideas are speculative, yes, but they remind us that what we call reality may not be the full picture. What we see as the totality of existence might just be the inside of one bubble, surrounded by a cosmos of bubbles that shape us in invisible ways. In the end, the multiverse forces us to confront a possibility we're not used to, that reality has no edge. There is no ultimate boundary, no final horizon. Every time we think we've reached the limit, there's something beyond it, something bigger, something stranger. Our universe, vast as it seems, may be just one chapter in a book, without end, one verse in an infinite poem of creation. And the question that lingers, the one that keeps returning no matter how far we stretch, is this. If there are infinite universes, what does that mean for us? Are we just one of endless versions repeating choices across realities? Or is there something unique about this particular bubble, something that makes our existence more than chance? The multiverse doesn't answer that. It only multiplies the mystery, replacing one universe with infinity, and leaving us to wonder if the truth is so vast that we will never be able to comprehend it. If the multiverse exists, then it is not a silent ocean of bubbles floating endlessly apart from one another. The rules of physics tell us that boundaries can touch, that regions of expanding space can overlap, that collisions are not just possible but perhaps inevitable. Imagine universes like soap bubbles drifting in an endless bath. Most float alone, isolated, expanding without interruption, but sometimes one bubble brushes against another. The impact ripples across their fragile skins, distorting them, scarring them, leaving behind faint imprints of the collision. In the grand scale of the multiverse, such a collision wouldn't look like two galaxies crashing into each other. It would look like two entire realities smashing together, each carrying its own version of space, time, and physical laws. And if our bubble ever touched another, the evidence might be written across the sky itself, hidden in the faint glow of the cosmos's earliest light. Scientists call this idea the cosmic bruise. When the Big Bang erupted into expansion, the young universe released a faint radiation, the afterglow of its birth. Billions of years later, we can still detect it as the cosmic microwave background, a near-perfect blanket of microwave light that surrounds us in every direction. It is the oldest picture of the universe we will ever have, a snapshot of the cosmos when it was only a few 100,000 years old. For decades, astronomers have studied this glow, searching for irregularities that might reveal the fingerprints of hidden events. And among the tiny fluctuations, some have wondered if faint circular patterns, unusual cold spots, or strange asymmetries could be the bruises of past collisions with other universes. If true, that would mean our bubble hasn't always been alone. It would mean our universe has already brushed against its neighbors, leaving subtle scars as proof. Of course, not everyone agrees. The evidence is murky, the patterns difficult to separate from random noise, but the very fact that cosmologists are seriously considering the possibility tells us something profound. the idea of colliding universes is not just science fiction. It is a consequence of inflation, a natural outcome of bubbles forming and expanding in the same cosmic sea. If there are countless universes inflating endlessly, collisions are unavoidable. And if collisions are unavoidable, then perhaps we are living in a universe that has already been reshaped by them. The consequences of such collisions are beyond imagination. If the physical laws of another universe differ even slightly from ours, the collision could be catastrophic. It might overwrite the structure of our cosmos, erasing galaxies, tearing apart atoms, replacing everything with the rules of the invading universe. Entire realities could be swallowed whole, their histories extinguished in an instant. Yet in other cases, the collision might be less destructive, leaving behind only subtle distortions, slight imbalances that ripple across the sky but allow life to go on. Our very existence might depend on the fact that if such collisions occurred in our past, they were gentle enough not to erase us. And here's the unsettling thought. If universes are still forming endlessly, if inflation never stops, then the threat of collision is not only a relic of the past, but a possibility for the future. Somewhere in the unseen depths of the multiverse, a bubble could already be expanding toward us. To us, it would arrive without warning. In an instant, the boundary between our universe and another would smash together, rewriting reality before we had time to blink. And because the speed of such an event would outpace even light, we would never see it coming. One moment we exist, the next we are replaced by the physics of another world. It's the ultimate existential dread, the idea that our universe could be erased not by its own internal decay, but by collision with another. But not all visions of cosmic collisions are apocalyptic. Some theories suggest that the Big Bang itself may have been the result of one. In this picture, our universe was born not from nothing, but from the impact of two higher dimensional brains, vast sheets of reality colliding in a space beyond our own. The energy of that collision ignited the expansion we call the Big Bang, and what we see as the beginning of time was really the aftermath of a cosmic crash. If so, then our universe is already the child of collisions, its very birth a scar from an ancient impact in a higher dimensional space. This idea, known as the akpirotic model, is speculative, but it offers an intriguing alternative to the notion of a singular beginning. Instead of a universe that simply appeared, we might live in one that was forged in the fire of impact, destined to be part of an eternal cycle of crashes and rebirths. It's difficult to convey how strange and yet how logical this all is. The universe we see is orderly, structured, predictable, governed by laws that allow us to build machines, predict orbits, and send signals across the sky. But beneath that order lies a reality where chaos reigns, where bubbles of space erupt, expand, and collide in an endless dance. The sky above us may look serene, but hidden within its oldest light could be the shadows of battles fought between universes, battles that shaped the one we call home. Even more unsettling is the thought that some of the mysteries we observe today may already be hints of these collisions. The cosmic microwave background contains anomalies, the so-called cold spot, for example, a region cooler than expected. Some scientists argue it is a statistical fluke. Others whisper that it could be the bruise of another universe pressing against ours. If that's true, then we have already glimpsed evidence of a multiverse not through speculation but through direct observation written in the sky. It's a possibility so radical that many hesitate to accept it, because it would mean our universe is not self-contained. It would mean we are living inside a bubble that has touched others, that our reality is not the pristine, isolated cosmos we once imagined. If this is correct, then the boundaries of our universe are not inviolable. They are fragile, permeable, open to contact with the unknown. That thought changes everything. It means the ultimate story of our cosmos may not be written within its own borders. It may be shaped by forces beyond, by collisions and interactions with realities we cannot see. The destiny of our universe may not be sealed by its own expansion or collapse, but by the chance meeting of bubbles in the endless sea. And if collisions happen, what happens to us? Does consciousness survive such an event? Does information, the most fundamental thread of reality, pass from one universe to another? Or is everything erased, rewritten, replaced by the rules of the incoming cosmos? We don't know. We may never know. But the fact that we can even ask these questions shows how far our understanding has come. We are no longer content to look at the stars and see only distant sun. We look at the sky and see the faint afterglow of the universe's birth, and in its patterns we imagine the scars of collisions with worlds beyond our own. Ultimately, the idea of colliding universes forces us to face the fragility of everything we take for granted. The galaxies, the laws of physics, even the flow of time itself, all of it may be contingent, temporary, vulnerable to forces outside our control. Our universe may be one bubble among countless others, drifting through a stormy ocean where collisions are inevitable. We don't know when or where they happen. We don't know if they create or destroy. All we know is that the possibility exists, written into the same physics that explains the stars above us. And perhaps the greatest mystery of all is not whether these collisions occur, but why. Against all odds, we are here in a bubble that has survived long enough to wonder about. For most of human history, we assumed the universe was built from indivisible pieces, tiny bricks that made up everything around us. The Greeks called them atoms, meaning uncuttable. Later science revealed that atoms themselves were not the final layer. They could be split into protons, neutrons, and electrons. And even those particles were found to be composites, made of quarks held together by gluons, all buzzing inside the quantum storm of reality. Each time we thought we had reached the bedrock of existence, the floor gave way, revealing something smaller, stranger, hidden beneath. Eventually physicists began to wonder, is there an ultimate level, a final note in the symphony of reality that cannot be divided further? This is where string theory enters the stage. According to this radical idea, the smallest building blocks of reality are not particles at all. They are vibrating strings, unimaginably tiny filaments of energy, each oscillating in different patterns. The vibrations determine what kind of particle emerges. One pattern produces an electron, another produces a quark. Another might generate a particle we've never seen. In this picture, the universe is like a vast cosmic symphony, and the strings are the instrument. Everything we see, matter, light, forces, is the music. Reality is not built from hard dots of matter, but from tiny loops of energy playing a hidden song. But the most shocking part of string theory is what it requires in order to work. Our familiar universe has 3 dimensions of space, length, width, and height, and 1 dimension of time. That's the fabric we move through, the backdrop for all our experiences. Yet when physicists tried to make the mathematics of strings consistent, they discovered that 4 dimensions weren't enough. The equations only balanced if the universe had 10 or even 11 dimensions. That means our reality might be far larger and stranger than we perceive, filled with hidden dimensions curled up so tightly we cannot detect them. Imagine holding a garden hose. From a distance, it looks like a one-dimensional line. But when you get closer, you see it has a circular dimension wrapped around it, a tiny loop hidden in plain sight. String theory suggests that the universe is like that hose. We move freely in 3 dimensions, but wrapped around every point are extra dimensions, compact and invisible, shaping the way strings vibrate. The properties of every particle, the strength of every force, the very structure of the cosmos, may depend on the geometry of these hidden dimensions. In other words, the secret architecture of reality is written in spaces we cannot see. If this sounds abstract, it is. The scales involved are so small that no microscope could ever reveal them. These dimensions are curled up billions of times smaller than the nucleus of an atom. Yet they may control everything. Why does gravity seem weaker than the other forces? Why does light behave the way it does? Why does our universe allow the existence of atoms and stars? String theory suggests the answers lie in the shape of these hidden dimensions. Different geometries produce different physical laws, and here is the shocking consequence. If the multiverse is real, then each universe might have its own configuration of hidden dimensions, giving rise to different particles, different forces, and entirely different realities. Take a moment to grasp what that means. The reason you exist, the reason atoms can form into molecules and molecules into living beings, may be nothing more than the result of how extra dimensions are folded in our universe. Change their shape even slightly, and everything changes. Perhaps no stable matter exists. Perhaps gravity crushes everything into black holes. Perhaps light cannot travel. In most configurations, life would be impossible. But in a few, the conditions are just right, and consciousness emerges to ask why. Our universe may not be fine-tuned in the way we think. It may simply be one of the few among countless possible string arrangements that allow life to exist. Some physicists describe this as the landscape of string theory, an almost infinite set of possible universes, each with different physical laws determined by the shape of extra dimensions. Our universe is just one valley in that landscape, and somewhere out there beyond our reach are universes shaped by dimensions so alien we cannot imagine them. In some, stars might never ignite. In others, time itself might flow differently. In still others, beings beyond comprehension might rise and fall, never knowing that their universe is one of many. And there is another twist. If strings are real, then the universe might not be confined to just our three-dimensional membrane. We may live on a brane, a sheet of reality floating in a higher dimensional space. Other branes could exist alongside ours, separated by distances we cannot measure because they lie across hidden dimensions. If so, then entire universes could be hovering next to us, closer than the width of an atom but unreachable, invisible, locked away by the boundaries of higher dimensional space. Occasionally, these branes might collide, unleashing energy on a scale we can barely imagine. Some theorists suggest that our Big Bang was one such collision, the crash of branes in higher dimensions releasing the fireball that became our universe. If true, then our universe is not unique, not isolated, but part of a grander cosmos where branes drift and clash endlessly, birthing new universes each time they meet. This picture is both exhilarating and terrifying. Exhilarating because it means reality is far larger and stranger than we ever dreamed. Terrifying because it means our existence is fragile, contingent on forces beyond our control. If brane collisions are real, then our universe could one day meet its end, not from within, but from outside, in a catastrophic crash with another brane. Just as easily as one collision created us, another could destroy us, wiping away our universe in an instant, and we would never see it coming, because the higher dimensional space where branes move is beyond our senses. Yet there is something almost poetic in this vision. Imagine universes drifting like vast sheets in a hidden space, colliding and separating, creating sparks of existence each time they meet. Imagine hidden dimensions shaping the song of strings, tuning the symphony of reality in infinite variations. Imagine that everything we see, the galaxies, the stars, our own consciousness, is just one movement in this eternal music, one note in a cosmic song played across dimensions we can never perceive. String theory offers a vision of reality that is at once dizzying and beautiful, a reminder that what we call the universe may be only the faintest shadow of something much larger. And perhaps this is why the theory, though unproven, continues to capture imaginations. It gives us a way to think beyond the limits of what we can observe. It suggests that the answers to the deepest mysteries, why the universe exists, why it has the laws it does, why life can emerge, may lie not in what we see, but in what we cannot see, in dimensions folded away, in branes drifting in higher spaces, in strings vibrating at scales too small for our eyes. We may never prove it. We may never detect the hidden dimensions direct, but the elegance of the idea, the way it weaves together gravity, quantum mechanics, and the possibility of infinite universes, makes it one of the most ambitious visions of reality humanity has ever conceived. And if even a fraction of it is true, then we are living inside a universe that is not ultimate, but provisional, not final, but one of many. Our cosmos may be a membrane floating in a higher ocean, a fragile sheet shaped by curled dimensions, vibrating with hidden strings, and somewhere out there, beyond the reach of our senses, other membranes drift. Other strings sing, other dimensions unfold their secret. We are part of a reality that is larger, deeper, stranger than anything we can yet imagine. A reality where the true nature of existence lies hidden in the folds of dimensions we can never see. When you look around at the world, everything feels solid. The floor beneath your feet, the air you breathe, the stars overhead, it all feels real, physical, three-dimensional. Space stretches out in every direction, and within that space, matter has substance. But what if all of it is an illusion? Not in the sense of being fake, but in the sense of being a projection, like a movie playing on a screen. This is the unsettling possibility suggested by the holographic principle, an idea born not from science fiction but from the cutting edge of physics. It suggests that our three-dimensional universe might actually be encoded on a distant two-dimensional surface, and everything we experience is the unfolding of that information into what looks like depth and volume. The story begins with black holes. For decades, black holes have been the ultimate paradox in physics. They are regions of space where gravity becomes so strong that not even light can escape. According to Einstein's theory of relativity, once something crosses the event horizon, the invisible boundary of a black hole, it is lost forever. Quantum mechanics insists that information can never be destroyed. The paradox is brutal. If black holes swallow everything, then information about what fell inside is gone. Yet quantum laws forbid such destruction. So what happens to it? Where does the information go? In the 1970s, physicist Jacob Bekenstein made a shocking discovery. He showed that the amount of information a black hole can contain, its entropy, isn't proportional to its volume, as you might expect, but to the area of its surface. In other words, the information about everything inside the black hole is somehow encoded on its outer boundary, the event horizon. Later, Stephen Hawking added to the mystery by showing that black holes aren't eternal. They slowly evaporate, releasing radiation. If they evaporate completely, does the information disappear, or is it somehow preserved on the horizon, waiting to be released? This puzzle led to a radical conclusion. Perhaps information is always stored on surfaces, not volumes. Perhaps our universe itself is no exception. This insight grew into the holographic principle, the idea that the entire three-dimensional universe could be described by information inscribed on a two-dimensional boundary. Just as a hologram on a flat sheet of film encodes a three-dimensional image, the cosmos might be a projection from a lower-dimensional surface. To us, it feels real, solid, and three-dimensional, but at its core, it could be nothing more than data, bits of information etched on a distant horizon. At first glance, this sounds impossible, almost insulting to common sense. How can galaxies, stars, planets, and people be nothing but encoded data on a surface we'll never see? But the mathematics supporting the idea is profound. In the 1990s, physicist Juan Maldacena proposed a concrete version of the holographic principle, showing that certain theories of gravity in a higher dimensional space could be exactly equivalent to quantum field theories in lower dimensions, without gravity. In simple terms, what happens in one dimension looks identical to what happens in another. This duality suggested that space itself, along with gravity, might emerge from deeper quantum information, projected into the form we experience. Reality, then, may not be fundamental. It may be emergent, a display of encoded data. If that is true, then everything we see and feel is part of a holographic story. The chair you sit on, the ground beneath your feet, the flow of time, all could be manifestations of information processed in ways we cannot comprehend. The solidity of matter might be an illusion, much like pixels on a screen appear smooth and continuous from a distance, but are discrete and limited when you zoom in. We may be living inside the projection of a cosmic hologram, mistaking the image for the source. The implications are staggering. If the holographic principle is correct, then space itself is not fundamental. Distance, location, the very geometry of the universe might all be illusions derived from information. And if space is emergent, then time might be too. What we call reality could be nothing more than the unfolding of information according to rules we've only begun to glimpse. The universe may not be a stage filled with matter and energy. It may be a story written in code, playing itself out as a holographic projection. And here's the unnerving twist. If information is the bedrock, then consciousness itself might be tied to it. What we experience as thoughts, memories, choices may not be products of neurons alone, but reflections of information woven into the holographic code. In that case, our awareness is not an accident of matter, but part of the structure of reality itself. Consciousness may be the lens through which the hologram reveals itself, collapsing probabilities into the story we perceive as life. Think about what this means for our sense of self. If the universe is holographic, then the boundary containing all information includes everything that ever was and ever will be. The birth of stars, the rise of civilizations, the flicker of every human thought, all of it might already be written into the code of the cosmos. Our lives, which feel fleeting and fragile, may be eternal in the sense that the information of them can never be erased. The holographic principle doesn't just hint at a different structure of reality. It whispers that nothing is ever truly lost. And yet this vision is not without its terrors. If we are part of a projection, then how much control do we really have? Are we participants in the code, or simply expressions of it? Are our choices real, or are they illusions emerging from data we cannot access? The holographic principle does not answer these questions, but it forces us to confront them. It blurs the line between reality and representation, between being and information. It asks us to consider that our sense of solidity, of permanence, is as fragile as light on a screen. The more physicists study the universe, the more evidence they find that aligns with this principle. The distribution of cosmic radiation, the mathematics of black holes, the properties of quantum entanglement, all seem to fit into a picture where space is emergent, not fundamental, and information is the true currency of reality. It's as if the universe is telling us that what we see is not what we get, that the truth lies hidden not in the stars, but in the invisible code projecting them. Imagine, then, what it means to live in such a universe. Every moment you experience, every breath you take, every dream you have, might be the unfolding of a deeper pattern, one etched on the distant horizon of reality. We move through space as if it were solid, but it may be nothing more than the shadow of information. We live in time as if it flows, but it may be the sequence of code revealing itself. The universe might be less like a machine and more like a cosmic film, unspooling frame by frame, its ending already encoded in the real. This does not make life meaningless. If anything, it makes it more mysterious, because if we are holograms, then we are holograms that can question themselves, projections that can look at the screen and ask what lies beyond. That ability itself may be the ultimate miracle of the code, that out of information came awareness, and out of awareness came the hunger to toe. The holographic principle doesn't diminish our place in the cosmos, it magnifies it, reminding us that even in a universe made of information, consciousness is extraordinary. Perhaps the strangest thought of all is this: if the holographic principle is right, then the ultimate reality is not what we see, but what we cannot see, not the galaxies above, but the surface encoding them. Our universe, vast and infinite to us, may be a mere shadow of a deeper reality. We are the flickers of a cosmic hologram, walking through a projection that feels real because it is real, real to us, the only kind of reality we can ever know. For centuries, science and philosophy have danced around one of the deepest mysteries of all. What is consciousness, and what role does it play in the universe? We are used to thinking of the mind as something that arises from the brain, a byproduct of neurons firing, a biological accident in an indifferent cosmos. But when you dig into the foundations of physics, when you push past the equations of relativity and the mathematics of quantum mechanics, you encounter something shocking. Reality itself may not be complete without consciousness. It may even be that the universe as we know it cannot exist without the act of observation, that the awareness inside your head is not a passenger but a participant in the unfolding of the cosmos. The evidence for this disturbing possibility comes from the very heart of quantum theory. In the strange world of the quantum, particles don't behave like the solid marbles we imagine. They exist in a haze of probabilities, occupying many states at once. An electron can be here and there, up and down, moving and not moving, all at the same time. This is called superposition, and it defies every instinct of common sense. But when we measure the particle, when we observe it, the superposition collapses. The electron is forced to choose. It is here, not there. It is up, not down. Reality crystallizes out of possibility only when it is observed. This is the famous observer effect, and it suggests that observation itself, awareness itself, plays a central role in turning potential into reality. The most iconic demonstration of this is the double-slit experiment. Fire particles at a barrier with two slits, and they act like waves interfering with each other, creating a pattern of ripples on the screen behind. But the moment you look to see which slit each particle passes through, the interference vanishes. The particles behave like solid bullets, choosing one slit or the other. Simply observing them changes their behavior. It is as if the universe is waiting to see if anyone is watching before deciding what form to take. For decades, physicists argued about what this meant. Some insisted it was just a quirk of measurement, a technical artifact of experiments, but others, including some of the greatest minds of the 20th century, dared to suggest something more radical. Consciousness is not outside the universe observing it. Consciousness is woven into the fabric of the universe, shaping it. In this view, reality does not exist in a definite form until it is observed, and the observer is not just a passive spectator but an active participant in creation. Think about the implications. If reality remains in a cloud of probabilities until it is observed, then what does that make the role of awareness? What does it mean for the world around you, for the solidity of the ground, for the stars overhead? Are they only real because they are being observed? And if so, by whom? Is it our individual consciousness that shapes reality? Or is there some deeper, universal awareness that collapses the wave of possibilities into the universe we share? This line of thought leads to an unsettling possibility. The universe needs consciousness. Without awareness to observe it, reality might remain nothing but a smear of probabilities, an unfinished equation. Our minds, fragile and fleeting as they seem, may be the key to existence itself. Perhaps life did not arise as an accident in the universe. Perhaps the universe is structured in such a way that it inevitably produces consciousness, because without it, nothing would ever fully exist. Consciousness, in this sense, may not be a latecomer to the cosmic story. It may be the very reason the story can be told at all. But there is another twist, one that pushes the mystery even further. If consciousness is required to collapse probabilities into reality, then how did the universe exist before conscious beings appeared? Who or what observed the cosmos in its early days before stars formed, before planets, before life? Some argue that the universe itself is aware in some way we don't understand, that consciousness is not limited to living brains but is a fundamental property of existence, woven into space-time the way gravity is. Others propose that the act of observation doesn't require human eyes, that interaction itself, particles colliding, forces exchanging, counts as observation, collapsing possibilities into outcome. But even these explanations leave open a deeper mystery. Why should the universe require observation at all? Why should reality care if it is being watched? The philosopher's answer is as unsettling as the physicist's. Perhaps reality is not separate from awareness. Perhaps they are two sides of the same coin. Just as you cannot have a coin with only one face, you cannot have a universe without consciousness, or consciousness without a universe. They arise together, bound in a loop that defies explanation. In this view, the universe is not a stage on which consciousness plays. The universe and consciousness are the same performance, inseparable, each bringing the other into being. If this is true, then the implications ripple outward into every corner of existence. It would mean that consciousness is not just a local accident on a small planet, but a cosmic principle, as fundamental as space and time. It would mean that awareness is not confined to our skulls, but is part of the very fabric of reality. And it would mean that the act of living, of perceiving, of asking questions, is not trivial but essential. Each moment of awareness is an act of creation, collapsing probabilities into the reality we share. You are not just living in the universe, you are helping to make it real. And yet, this possibility also raises disturbing questions. If reality is shaped by observation, then what happens when no one is watching? Does the universe vanish into probability clouds waiting for the next conscious gaze? Do galaxies billions of light years away exist only because they are observed indirectly by photons captured in telescopes? Does the moon exist when no one looks at it? Or does it wait, suspended in uncertainty until awareness collapses it into place? Albert Einstein once famously joked, "Do you really believe the moon isn't there when you're not looking at it?" But in the quantum view, that question may not be as ridiculous as it sounds. The role of consciousness in shaping reality is still debated, still unresolved, still deeply controversial. Some physicists reject it outright, preferring interpretations of quantum mechanics that avoid placing awareness at the center. But others remain intrigued, unwilling to dismiss the possibility that the universe is more participatory than we imagine. And even if consciousness does not collapse probabilities in the strict sense, there remains the undeniable fact that without awareness, the universe has no meaning. The cosmos without conscious beings to perceive it is a cosmos without story, without experience, without reality as we understand it. Awareness may not only shape the universe physically, it may define it existentially. If that is the case, then our role in the cosmos is far greater than we usually imagine. We are not insignificant observers in a vast indifferent space. We are participants in reality's unfolding, partners in creation, the eyes through which the universe sees itself. Consciousness may be the mirror the universe holds up to itself, the way possibility becomes actuality. And if so, then the most profound truth may be this: without consciousness there is no reality, and without reality there is no consciousness. Each depends on the other, locked in a dance older than time, deeper than space, more mysterious than any law of physics. And perhaps that is why we feel so compelled to ask questions, to peer into the unknown, to wonder why there is something rather than nothing. The very act of questioning may be part of the mechanism by which reality becomes real. Curiosity itself may be the spark that lights existence, the way awareness shapes the cosmos. If that is true, then our search for meaning is not futile. It is the heartbeat of the universe, the pulse of creation itself. Every time we look, every time we measure, every time we wonder, we are not just observing the universe, we are helping to bring it into being. The universe is not just expanding, it is accelerating. That revelation made in the late 1990s shattered everything we thought we knew about the cosmos. For decades, astronomers believed the Big Bang had set space in motion, and that gravity, the great attractive force, was gradually slowing the expansion. Maybe it would slow forever, never stopping but gradually easing into stillness. Maybe it would one day reverse, pulling everything back together in a final collapse. Either way, gravity was supposed to be in charge. But when two teams of scientists measured the light from distant supernovae, they found something shocking. The galaxies were not just drifting apart, they were racing away faster and faster. The universe was accelerating, driven by something unknown, something invisible, something stronger than gravity itself. That force has come to be called dark energy, and it is perhaps the greatest mystery in all of science. To grasp the scale of this enigma, imagine the universe as a vast fabric. Every galaxy is a point stitched into that fabric, and expansion is the stretching of the cloth. Gravity tugs the stitches together, trying to hold them close, but something else is at work, something that pulls the fabric apart with relentless force. This is dark energy, the hidden driver of acceleration. We don't know what it is, we don't know where it comes from, but we know its effect, and that effect is staggering. Dark energy makes up about 70% of the entire universe. That means most of the cosmos is made of something we cannot see, cannot touch, cannot understand. Everything we've ever known, stars, planets, matter, life, accounts for less than 5%. The rest is dark energy and dark matter, the invisible scaffolding and hidden fuel of reality. The first thought many physicists had was that dark energy might be the cosmological constant, a term Einstein himself once introduced into his equations. When Einstein first developed general relativity, he realized the equations allowed for a universe that was either expanding or contracting. But in 1917, the idea of an expanding universe seemed absurd, so he added a constant, a mathematical trick to balance gravity and keep the universe static. Later, when expansion was discovered by Edwin Hubble, Einstein abandoned the constant, calling it his greatest blunder. But perhaps it wasn't a blunder after all. Perhaps the cosmological constant is real, a kind of vacuum energy, an invisible pressure built into space itself. In this picture, every cubic centimeter of space contains a tiny amount of energy, and as space expands, more space means more energy, pushing expansion faster and faster. But this explanation only deepens the mystery. When physicists calculate how much vacuum energy there should be according to quantum mechanics, the numbers are catastrophically wrong. They predict an amount of energy 10 times larger than what we actually observe. That is a number so absurd it is almost impossible to comprehend. If theory were correct, the universe would have blown apart instantly, never forming stars, never forming galaxies, never forming us. Instead, the vacuum energy we measure is tiny but nearby, just enough to accelerate expansion slowly over billions of years. Why? No one knows. It is perhaps the biggest mismatch between theory and observation in the history of science, a clue that something profound is missing from our understanding, and dark energy may not even be constant. Some theories suggest it could change over time, that it is not a fixed property of space, but a dynamic field. Slowly evolved physicists call this quintessence, borrowing a word from ancient philosophy that meant the fifth element beyond earth, air, fire, and water. If quintessence is real, then dark energy might wax and wane, shaping the future of the cosmos in unpredictable ways. Perhaps it will fade away, allowing gravity to slow expansion again. Perhaps it will grow stronger, tearing galaxies apart, then stars, then atoms themselves in a final apocalypse known as the Big Rip. The fate of everything depends on what dark energy is, and yet we stand in almost total ignorance, peering at its effects but unable to see its nature. Still, we know this much. Dark energy is not optional. The evidence is overwhelming. Observations of supernovae, the cosmic microwave background and the distribution of galaxies all point to the same conclusion. Something unseen is pushing space apart, and the strangest part is that this pushing does not dilute as the universe grows. Ordinary matter thins out as space expands, spreading like butter on bread. But dark energy seems to stay constant or nearly so, always dominating, always driving. It is as if the universe has built-in fuel, inexhaustible, woven into the very fabric of existence. The consequences are staggering. As expansion accelerates, galaxies drift farther and farther away. Already, most galaxies in the universe are receding from us faster than the speed of light, carried by the stretching of space. We will never see them. Their light will never reach us. In the distant future, billions of years from now, the night sky will grow emptier as galaxies slip beyond the cosmic horizon, leaving only our local group, Andromeda, the Milky Way, and a few dwarfs as the last island of stars. To future observers, the universe will appear dark and lonely, stripped of evidence that anything else ever existed. They will not see cosmic expansion. They will not detect the glow of the Big Bang. To them, the universe will appear static, eternal, unchanging. The clues that led us to discover dark energy will be gone. We live in a rare moment when the cosmos reveals its secrets, and those secrets tell us that most of existence is ruled by a force we cannot explain. And this is perhaps the most haunting truth. If dark energy is real, it means the fate of the universe is sealed not by matter, not by stars, but by emptiness. Space itself is the driver of destiny. If the cosmological constant is truly constant, then expansion will continue forever, accelerating endlessly. Stars will burn out, galaxies will fade, black holes will evaporate, and the universe will drift into a cold, dark silence, expanding faster and faster into nothingness. That is the heat death of the cosmos, not a fiery end, but an eternal freezing, where space grows infinite, and all energy is spread so thin that nothing happens anymore. Time itself may lose meaning in that endless stillness. But if dark energy changes, the story could be different. It could lead to collapse, to rip, to rebirth. Some theorists suggest cycles of expansion and contraction, a universe that breathes in and out, forever destroyed and recreated. Others speculate that dark energy might be the echo of other universes pressing against ours, that its mysterious push is not intrinsic at all, but a side effect of collisions in the multiverse. And some dare to suggest that dark energy is tied to consciousness, that the same mystery linking awareness to quantum mechanics might also link it to the fabric of expansion. These ideas are unproven, perhaps unprovable, but they remind us of one thing. Dark energy is not just another puzzle, it is the puzzle. It defines the fate of the cosmos itself. When we look into the night sky, we are not just looking at stars, we are looking at the battle between gravity and dark energy, a battle gravity has already lost. Every flicker of light we see is being pulled away, accelerated into the abyss. We are clinging to one tiny island in a universe that is drifting apart faster and faster, carried by a current we cannot resist. And yet, we are aware of it. We see it. We name it. That awareness may be the most extraordinary thing of all, that in a universe dominated by dark energy, fragile beings made of matter can glimpse the invisible hand shaping their destiny. We may not understand dark energy, but the fact that we can ask about it, measure it, argue about it, means something. It means that even as the cosmos speeds toward an unknowable future, there is consciousness here now, looking into the dark and asking why. Perhaps that is the real legacy of dark energy. Not just that it accelerates the universe, not just that it will determine our fate, but that it forces us to confront how little we know. It humbles us, reminding us that the cosmos is not built to be understood easily. It is vast, mysterious, filled with forces we cannot see and cannot control. And yet, even in that vastness, even in that mystery, we find wonder. We find the courage to ask. We find the drive to keep looking. And maybe that, more than anything else, is what makes the universe meaningful. That in a reality dominated by darkness, we still search for light. The universe has a beginning, or at least that is what the Big Bang suggests. But if it has a beginning, does it also have an end? From the moment humans first gazed at the stars, we have wondered not only how they were born, but how they will die. And what will become of the cosmos when everything we know is gone? Will the universe collapse into itself, erased in a final implosion? Will it freeze in eternal silence, expanding into emptiness forever? Or will it meet an ending so bizarre, so unimaginable, that our current science can barely whisper its outlines? To ask about the fate of the universe is to ask about the fate of time itself, because in the end, what is time without change, without events, without life? Time might not continue forever. it might stop, and that thought is as haunting as it is profound. The most widely accepted vision of the end is called heat death, the inevitable consequence of an eternally accelerating universe driven by dark energy. In this picture, galaxies drift farther and farther apart, carried by the relentless expansion of space. Stars burn out one by one, leaving only the cold embers of white dwarfs, neutron stars, and black holes. For a while these remnants shine faintly, but even they will fade as their energy is exhausted. Black holes will swallow the last light, hoarding mass until even they begin to evaporate through Hawking radiation. Over unimaginable spans of time, even the black holes will vanish, leaking their energy back into the cosmos. What remains is a thin, featureless soup of particles spread across infinite space. No stars, no galaxies, no structures, no movement. In such a universe there is no arrow of time, because nothing changes. Time, which we measure by events, would lose meaning in the eternal stillness. The universe would not explode, not collapse, but fade into an endless silence, a cosmic graveyard without memory. But heat death is not the only possibility. Some theories suggest the universe might end in a far more violent way. If dark energy grows stronger with time, it could one day rip the cosmos apart in an apocalypse known as the Big Rip. In this scenario, acceleration does not slow or remain steady. It increases, tearing galaxies apart, then solar systems, then planets, then atoms themselves. Gravity, electromagnetism, even the forces binding nuclei would fail in the face of runaway expansion. The very fabric of matter would be shredded, until nothing remained but a storm of particles flung into oblivion. The Big Rip is a horrifying vision, a universe not fading quietly but ending in chaos, with every bond broken and every structure destroyed. Other possibilities lean in the opposite direction. What if dark energy is not constant but temporary? What if one day it fades, allowing gravity to take control again? In that case, expansion could slow, stop, and reverse. The universe would begin to contract. Galaxies drawing closer, stars colliding, everything heating as space itself shrinks. Eventually, all matter and energy would collapse into a single point, a reversal of the Big Bang called the Big Crunch. Time itself might end in that collapse, crushed into the singularity from which it began. And some theorists suggest that from that singularity, a new Big Bang could erupt, birthing another universe in an eternal cycle of death and rebirth. If so, then our universe is not the first, and it will not be the last. It is one breath in the infinite breathing of reality. There are even stranger endings proposed. Some physicists suggest that our universe could decay, not gradually but suddenly, through a process known as vacuum decay. If our universe is not in its true lowest energy state, it could one day transition into a lower state, unleashing a bubble of new physics that expands at the speed of light. Inside the bubble, the laws of nature would be different. Atoms would dissolve, chemistry would fail, life would be impossible. And because the bubble would travel faster than light, we would never see it coming. One moment we exist, the next we are gone, erased by the rewriting of the cosmos. It would not be painful, because it would be instantaneous, but it is a chilling possibility that the end of the universe might come not in trillions of years, but in any moment without warning. Yet perhaps the strangest idea of all is that time itself may not be fundamental. Some physicists propose that time is emergent, not a basic ingredient of reality, but a byproduct of deeper processes. If that is true, then time could end not because the universe reaches a physical limit, but because the underlying process that generates time stops. Imagine reading a novel. The story feels like it flows forward, one event after another, but the entire book already exists, every page written from beginning to end. Our experience of time might be like reading that book, a passage through an already written structure. The end of time, then, would not be the destruction of the universe, but the closing of the book, the final page turned. From the inside, it feels like an ending. From the outside, perhaps it is all timeless, all already complete. In the face of these possibilities, one question lingers. Does the end of the universe mean the end of meaning? If everything collapses, fades, or rips apart, does it erase the significance of what came before? Some argue, yes, that if the universe ends in silence, then everything we do is temporary, destined to be forgotten. But others argue the opposite, that meaning does not require eternity. A song does not lose its beauty because it ends. A life does not lose its value because it is finite. The universe, too, may be meaningful precisely because it has a beginning and an end, a story that unfolds across cosmic time, brief or long, fragile or immense. And there is another layer. If the multiverse is real, then our universe's death may not be the end of everything, only the end of this particular bubble. Other universes may continue, or be born from ours, each carrying on existence in its own way. From that perspective, death is not absolute, it is transformation. Our universe may be one note in an endless symphony, one spark in a fire that never goes out, and if consciousness is fundamental, as some theories suggest, then perhaps awareness persists in ways we cannot imagine, woven into the fabric of reality even after stars and galaxies are gone. The end of time may not be the end of being. What is certain is that the universe will not last forever in its current form. Whether it ends in heat death, rip, crunch, or decay, change is inevitable. And we who live in the briefest flicker of cosmic history are privileged to know this. The stars above us are not eternal, the galaxies are not permanent. Even time itself may not endure. And yet in this fleeting moment we are here, able to ask, able to wonder, able to see. Perhaps that is the real miracle. Not that the universe will last forever, but that we exist within it long enough to know it will not. When we ask about the universe, we often ask how. How did it begin? How will it end? How do stars form? How do galaxies evolve? How does life arise? Science has given us remarkable answers to these questions, tracing the story of matter and energy across billions of years. But beneath the how lies a question more fundamental, more haunting, one that no equation has yet solved. Why is there something rather than nothing? Why does reality exist at all? Why is there a universe for science to describe, for us to inhabit, for consciousness to experience? This is the ultimate mystery, the one that sits at the edge of knowledge, mocking every attempt to explain it. At first glance, the question seems almost absurd. Of course, something exists, because here we are to ask about it. But when you strip everything away, the galaxies, the stars, the particles, even space and time themselves, you are left with the possibility of nothing, a true void with no laws, no fields, no dimensions, no being. Why isn't that the case? Why does the universe insist on existing, on being something rather than nothing? Some philosophers argue that the question is unanswerable, that existence is a brute fact, requiring no explanation. But others refuse to accept that. They believe that understanding why the universe exists may be the key to understanding everything. One possibility is that existence is inevitable, that nothingness is unstable, and given the chance, it will always produce something. This idea finds echoes in quantum mechanics, where empty space is never truly empty. Even in a perfect vacuum, particles flicker in and out of existence, born from fluctuations in energy. If the laws of physics allow such fluctuations, then perhaps the universe itself is the result of a grand quantum fluctuation, reality bubbling out of nothingness, because nothingness could not hold. In this view, existence is not a mystery but a necessity. Nothingness is impossible, because even the void contains potential, and from that potential, universes inevitably arise. But this explanation raises its own problems. If the universe is a quantum fluctuation, then it depends on the laws of quantum mechanics, and those laws themselves exist. They are something. Why do they exist? Why do the rules of mathematics and physics hold at all? We might explain the universe by appealing to laws, but we cannot explain the laws themselves. They seem to stand outside of existence, timeless, waiting to give rise to reality. But why should they be there? Why should the rules of possibility exist, rather than no rules at all? Others suggest that the universe exists because of mathematics itself. The mathematician Max Tegmark has argued that reality is not just described by math, but is math. In this view, the universe exists because numbers exist, and all mathematical structures exist equally. Our universe is one such structure, experienced by beings capable of perceiving it. In other words, existence is not a mystery, but an inevitability. If mathematics exists, then so does everything mathematics describe. Nothingness in this view is not even coherent, because the existence of mathematical truths cannot be erased. 2 plus 2 equals 4, whether or not a universe exists to contain it, and from those truths, existence emerges. Yet this idea, too, is unsettling. If all mathematical structures exist, then every possible universe exists, every configuration of laws, every arrangement of matter and energy. We live in one because we can, because it allows conscious observers to arise. But that leaves us no closer to answering why mathematics exists at all. Why should abstract truth become concrete reality? Why should numbers bleed into being? The question keeps slipping away, no matter how many layers we peel back. Some thinkers have turned to the anthropic principle for comfort. The anthropic principle says that the universe must be the way it is, because we are here to observe it. If the laws were different, we would not exist, and we would not be asking the question. In that sense, the universe's existence is not surprising. It is the precondition for our existence. But this feels like a circular answer. It tells us why we experience a universe suitable for life, but not why the universe exists at all. It explains our presence, but not the presence of everything. Religion and philosophy offer their own answers. Some say the universe exists because it was created, because a creator chose something over nothing. Others argue that existence itself is divine, that the universe and God are one, and being is eternal. But these answers too push the mystery back a step. Why should God exist rather than nothing? Why should there be a creator at all? The question of why there is something rather than nothing is like a horizon. Each time we approach it, it recedes, drawing us deeper into mystery. And yet, perhaps the question itself reveals something profound. To even ask it is to acknowledge the strangeness of being. We take existence for granted, but it is the greatest miracle of all. Every star, every atom, every thought depends on it. Without existence, there is nothing, not even the concept of nothing. That we are here, aware, capable of asking why, is itself astonishing. Perhaps the answer is not that the universe exists for a reason, but that existence is the ground of all reason, the one fact that needs no further explanation. Perhaps the question why is there something is unanswerable, not because we lack knowledge, but because it presupposes a contrast, something versus nothing, that may not truly exist. Still, the mystery lingers. Scientists, philosophers, and dreamers cannot resist asking. Some imagine that existence is cyclical, that universes come and go, with no beginning and no end. In such a framework, the question of why may not apply, because existence simply is, eternal and uncaused. Others wonder if our universe is simulated, created by beings in another reality. If so, then we exist because someone chose to simulate us. But even then, the question remains, why do they exist? Why does the computer exist? Why does the higher reality exist at all? The question is relentless, refusing to be silenced. And maybe that is the point. Maybe the question is not meant to be answered, but to be lived. The fact that we can ask it, that consciousness can reflect on being itself, may be the greatest mystery of all. Why should particles, born from the fire of the Big Bang, assemble into beings who wonder why anything exists? Why should matter give rise to awareness that questions its own source? Perhaps the universe exists so that it can be aware of itself, so that nothingness could not remain nothingness but blossomed into something capable of asking why. What is certain is this: existence is not inevitable to us. It feels fragile, contingent, improbable, and that fragility is what makes it precious. The fact that there is something rather than nothing is not only a mystery but a gift, the foundation of every moment, every thought, every life. We may never know why. We may never pierce the veil of ultimate truth, but we can marvel at the fact of being, at the reality that there is a universe, that there are stars, that there is life, that there is awareness. Perhaps that is enough. Perhaps the mystery of existence is not one to solve, but one to experience, to live fully, knowing that we are part of the greatest miracle of all, that there is something and that we are here to see it. When we reach the edge of understanding, when science, philosophy, and imagination all collide, we find ourselves staring into the deepest question of all, not just why anything exists, but what role we play in this vast and unfathomable drama. The universe stretches across billions of light years, ruled by forces we barely comprehend, ending in possibilities we can only describe with metaphors. And yet within this immensity, life has appeared, fragile, improbable, conscious. It is almost absurd to think that out of all the forces at work, all the randomness, all the vast indifference, there arose something that can look at the stars and wonder what they mean. And it is here in this moment of reflection that section 13 begins. the mystery of human significance in a cosmos that appears infinite, indifferent, and possibly eternal. For some, this significance is an illusion. They say we are nothing but accidents of chemistry, temporary arrangements of atoms destined to dissolve. In a universe filled with trillions of galaxies, each with billions of stars, the Earth is less than a grain of dust. Why should our lives matter? From this perspective, asking about meaning is as futile as asking why one snowflake should matter in a blizzard. And yet, if you step back, if you let go of the scale of size and think instead about the scale of consciousness, the picture changes. The blizzard does not know the stars do not reflect, the galaxies do not ask questions, but we do. That alone makes us different. That alone gives significance to the human story. Perhaps significance is not about size, permanence, or power. Perhaps significance is about awareness. A universe without consciousness is just matter in motion, silent and unknowing. A universe with consciousness is one that can see itself, question itself, give itself meaning. In that sense, the human story is not small but monumental. We are the eyes of the cosmos, the neurons of the infinite, the part of reality that has awakened and said, I am here, and I want to know why. And yet, this realization leads to another mystery. Why is consciousness so rare? As far as we know, Earth is the only planet where life has reached this level of awareness. Billions of stars, billions of galaxies, and yet silence. No signals, no messages, no evidence of others like us. This is the Fermi paradox. If the universe is so vast, where is everyone? Some argue that life must be common, but intelligent life rare, fragile fluke in the chaos of evolution. Others suspect that civilizations rise and fall quickly, burning themselves out before they can spread across the stars. And some suggest darker answers, that the silence is not an accident but a design, that universes might be structured to limit consciousness, to ensure awareness arises only briefly, sparingly, before vanishing into the void. But maybe the silence is not a warning but an opportunity. Maybe we are the first or among the first to awaken. If so, then our role is far greater than we realize. We are not just one species on one planet. We are the pioneers of cosmic awareness, the first flicker of the universe becoming conscious of itself. And if we can survive, if we can endure beyond our fragile moment, then perhaps we will carry awareness to the stars, spreading life, memory, and meaning into the darkness. In that sense, the fate of consciousness may rest on us. The cosmos has produced eyes, voices, stories, but whether those eyes will close forever or expand into infinity depends on what we do now, in this fleeting moment of cosmic history. This is where science and philosophy blur into something deeper. If consciousness shapes reality, as some interpretations of quantum mechanics suggest, then our role is not just to survive, but to participate in creation itself. Every observation, every thought, every act of awareness may be part of the mechanism by which the universe becomes real. And if so, then human significance is not an illusion at all. It is woven into the fabric of existence. The stars may be larger, but without us they are silent. With us they are seen, named, and understood. Meaning does not exist apart from us. Meaning exists because of us. Still, one cannot escape the weight of the unknown. What if our significance is temporary? What if the heat death, the big rip, or vacuum decay wipes us out before we can carry consciousness further? What if awareness is destined to be brief, a spark in the darkness that fades without a trace? That possibility is sobering, but it does not erase meaning. The spark is still light, however brief. The question is still profound, even if it has no answer. The very act of asking why there is something, why we are here, why we are conscious, that act is significance itself. Perhaps the cosmos gave rise to life for this reason alone, to ask the questions it cannot answer for itself. And here lies the paradox of human existence. On one hand, we are small, fragile, temporary. On the other hand, we are vast, because within our minds the universe reflects on itself. Within our thoughts, galaxies and black holes, dark energy and hidden dimensions become ideas. Within our stories, the cosmos is not just matter but meaning. We are not apart from the universe. We are the universe. Become aware, become curious, become alive. That is not arrogance. That is truth. But then comes the final twist, the one that leaves even the most rational minds unsettled. If the universe exists because it is observed, And if consciousness is part of its foundation, then what happens when consciousness ends? If the last observer fades, does reality itself fade with them? Does the universe return to probability clouds, uncollapsed, unrealized? Or does awareness persist beyond the individual, beyond the species, woven into the laws of existence themselves? We do not know. We cannot know, but the question itself reveals our place in the story, fragile yet essential, fleeting yet cosmic. So what, then, is Section 30? It is the confrontation with this paradox. It is the moment when we acknowledge that meaning is not handed down from the stars, nor hidden in equations, nor written in stone. Meaning is created by awareness, by the fragile spark of consciousness daring to ask questions the universe cannot answer on its own. The ultimate mystery may not be why the universe exists, or how it will end, but why it gave rise to beings who wonder at all. And perhaps the answer is as simple as this: because it could, because nothingness could not hold, because laws exist, because mathematics breathes, because probability collapsed into being, and being produced awareness. And once awareness arose, the question became inevitable. The universe exists so that it could be asked about. We exist because the story required someone to tell it. And in that sense, even if everything ends, even if time itself stops, the act of having been aware even once gives the cosmos meaning it could never have otherwise had. So the story continues. Perhaps in other universes, other beings ask their own versions of these questions. Perhaps in this universe we will carry awareness to the stars, filling the silence with voices. Or perhaps we will fade, leaving the cosmos empty again. Either way, significance is not about eternity. It is about presence. It is about the fact that right now, here, in this moment, there is something rather than nothing. There is life rather than silence. There is awareness rather than void. And that is enough. When you push past the boundaries of science and philosophy, when you step into the silence that lies beyond equations and theories, you reach a question more unsettling than any other. What comes after the end? Not just the end of stars, galaxies, or even universes, but the end of endings, what lies beyond time itself. If the universe collapses, rips apart, or fades into stillness, is that the final word, or is there something more, something hidden beyond the horizon of physics? This is not simply a scientific question, it is the ultimate human question, the one that touches meaning, destiny, and eternity all at once. And it is here, in this final layer of mystery, that we find the ground for section. Let us imagine the heat death again, a universe of silence, no stars, no light, no change. From within it seems eternal, a perfect void, stretched over infinite space. But what if that is not the end? What if within the stillness fluctuations begin to stir again? Physics tells us that even in emptiness, even in the deepest void, quantum fluctuations bubble. Particles emerge, pairs form and annihilate. Over vast timescales, could these fluctuations give birth to new structures, even new universes? Could heat death be not the end, but the pause between movements in a cosmic symphony that never stops? In this vision, universes are born endlessly, not in one singular Big Bang, but in countless bursts of being, each rising from the ashes of silence. Now, consider the Big Rip. Space tears apart, atoms shredded, reality unraveled. At first glance, it is annihilation absolute. But if higher dimensions exist, if brains drift and collide, perhaps the destruction of our cosmos is not the end, but the beginning of another. The energy released by such a tear might cascade into new dimensions, sparking other universes, other realities, other stories. From our perspective, it is death. From the larger perspective of the multiverse, it is rebirth. Endings and beginnings blur, merging into an endless cycle where nothing is ever truly final. And then there is the question of consciousness. If awareness is fundamental, if observation shapes reality, then what happens to consciousness when the universe ends? Does it dissolve with matter, a flicker extinguished, or is it woven into the structure of reality itself, persisting beyond space and time? Some philosophers and physicists have dared to suggest that consciousness may not be bound to the brain, but to information, and information, according to the laws of physics, can never be destroyed. If that is true, then perhaps awareness is not erased at the end of time. Perhaps it flows onward, transformed, reborn in ways we cannot imagine. Perhaps what we call death of a star, a galaxy, a universe, even of a person, is never final, but always transition. It is here that speculation reaches its most daring heights. Some propose that our universe is itself a simulation, running on structures outside of space and time. If so, then the end of the universe may not be the end at all, but the closing of a program, the shutting down of a simulation that can be restarted, rewound, or copied. In that case, endings are illusions, artifacts of perspective. The larger reality, the one beyond the simulation, may continue unaffected, and if that is true, then what we call existence may be only a shadow, fragment of something larger that transcends even universes. Others suggest that the universe exists not for matter, not for stars, but for meaning, that the purpose of existence is to create awareness, to generate questions, to give rise to beings who can ask why. In this framework, the end of the universe is not an erasure but the fulfillment of purpose. Once awareness has arisen, once meaning has been created, the cosmos has achieved what it needed to achieve. The ending, however it comes, is simply the completion of the story. Just as a book does not lose its meaning when it ends, the universe does not lose its purpose when it fades. Its value lies in having been, not in lasting forever. And yet, we cannot resist the thought that perhaps there is more. Perhaps the end of this universe is not the end of all universes, nor the end of consciousness, nor the end of being. Perhaps what comes after is something beyond imagination, something no equation can capture, no telescope can see, the realm beyond time, where existence and non-existence merge, where being and nothingness are the same, where the very distinction between something and nothing dissolves. In such a place, the question of why anything exists at all might no longer make sense because the categories of anything and nothing would no longer apply. And maybe that is the ultimate lesson of the universe, that our questions, as profound as they are still shaped by the limits of our perspective. We ask about beginnings and endings because we live in time. We ask about something and nothing because we live in contra. But perhaps reality in its deepest form is beyond these categories. Perhaps it is not a story with a beginning and end, but a presence, eternal and unbounded, that gives rise to all stories without itself ever changing. We glimpse it in mathematics, in the inevitability of numbers. We glimpse it in consciousness, in the mystery of awareness. We glimpse it in the stars, in the fire of the Big Bang, but we never see it fully because we are part of it, inside it, unable to step outside and view it whole. This realization is humbling, but it is also liberating. It means we do not need final answers to live meaningfully. We do not need to know why the universe exists, or how it will end, or what lies beyond time, to find wonder. Wonder exists now in the fact of being. Significance exists now in the act of asking. Meaning exists now in the awareness that contemplates the infinite. Whether the universe ends in silence, collapse, or rebirth, it cannot erase the fact that we were here, that we asked, that we sought to know. So what comes after the end? Perhaps more universes, perhaps nothing, perhaps something we cannot name. But what matters is not only what comes after, but what is happening now, this moment of existence, this brief flicker of consciousness in the vast sea of being. The end may be inevitable, but it is not here yet. And until it comes, the universe is alive, full of stars, full of mystery, full of meaning. And maybe that is the greatest truth of all, that endings are never absolute, because awareness transforms them. Even the thought of the end is itself part of the story, part of the meaning we create. The universe may fade, but the fact that we existed, that we asked, that we dreamed, will always remain, woven into the fabric of reality in ways beyond our comprehension. We are not powerless before the end. We are its witnesses, its storytellers, its meaning makers, and that makes us eternal in a way no heat, death, or big rip can erase. When we look back at everything we've explored, the birth of the universe, the mysteries of quantum mechanics, the fate of stars, the silence of the cosmos, the possibility of multiverses, and the haunting question of why anything exists at all, we begin to see a pattern emerging. It is not the neat pattern of a solved puzzle, where every piece fits into place. It is the sprawling pattern of a tapestry still being woven, with threads stretching into the unknown, some tangled, some frayed, but all part of something larger than we can yet imagine. Section 15 is the moment when we step back from the details and take in the whole view, when we realize that the story of the universe is also the story of us, and that the mystery of everything is inseparable from the mystery of our own awareness. The first truth is this: the universe is not small. It is vast beyond measure, and even our most advanced telescopes can only peer into a fraction of its depth. Trillions of galaxies, countless stars, unimaginable distances. We are confronted with immensity so great it defies comprehension. But the second truth is more shocking. In all that immensity, life is rare, consciousness rarer still. As far as we know, in the entire expanse of reality, we are the only beings asking these questions. That fact alone gives us a role we cannot escape. Whether by design or by accident, we are the storytellers of the universe, the witnesses of its beauty, the thinkers who dare to wonder why. The third truth is that the universe is fleeting. Stars are born and die, galaxies collide and scatter, and even the laws of physics may change over time. Our world, so solid beneath our feet, is temporary. The Earth will not last forever, nor will the Sun, nor even the galaxies that surround us. One day, the universe as we know it will end. This knowledge is sobering, but it is also liberating. It forces us to confront the fact that permanence is an illusion, that meaning cannot be found in eternity, but in the present moment, in the act of being itself. And the fourth truth, the deepest of all, is that consciousness is a mystery greater than any star. We know how stars burn, how planets orbit, how galaxies spiral, but we do not know why atoms arranged in certain ways give rise to awareness, to thought, to the feeling of being alive. Consciousness is the thread that ties everything together, the light in which the universe becomes visible. Without it, there is no story, no beauty, no meaning. With it, everything changes. If observation collapses quantum possibilities into reality, then awareness is not just a product of the universe but a participant in its creation. We are not just watching the cosmos, we are helping it unfold. When these truths are seen together, they transform the way we think about existence. The universe is vast, fleeting, mysterious, but it is also alive because we are alive within it. It is meaningful because we give it meaning. It is aware because we are aware of it, and this awareness, fragile though it may be the most powerful force in existence. A star burns without knowing it burns. A galaxy spins without knowing it spins. But we look at the stars, we map the galaxies, we tell their story. In that act, we become more than matter. We become meaning. So what does it all add up to? Perhaps it adds up to this. The ultimate purpose of the universe may not be survival, permanence, or power. It may be awareness. It may be that the cosmos exists so that questions can be asked, so that curiosity can arise, so that meaning can be created. In that sense, every conscious being is an expression of the universe's deepest truth, a way for existence to look at itself and marvel. And if that is true, then our role is not trivial. It is essential, and yet we cannot escape the silence of the unknown. Beyond all our theories, beyond all our imagination, there remains the question we cannot answer. Why is there something rather than nothing? Perhaps we will never know. Perhaps the question itself is flawed, a reflection of human logic applied to a reality that transcends it. But even if the answer eludes us forever, the asking is not in vain. To ask is to participate in the mystery. To ask is to affirm that existence is not meaningless, that it is worthy of wonder. The question itself is the meaning. Some may find this unsatisfying. They want an answer, a final truth, a definitive explanation. But maybe the universe is not a riddle to be solved, but a story to be lived. Maybe the point is not to reach the end, but to marvel at the journey. Maybe the meaning of existence is not found in the why, but in the fact that we exist at all, that we are here, that we are aware. And maybe, just maybe, that is enough. The cosmos is not ours to control, but it is ours to experience. We cannot prevent the stars from dying, the galaxies from drifting, the universe from ending, but we can live here and now, in the light of awareness, in the miracle of being. We can tell stories, seek truth, create beauty, love, dream, and wonder, and in doing so, we transform existence. We make the universe meaningful, not because it needed us, but because we are part of it. In the end, the greatest mystery may not be the Big Bang, or dark matter, or the multiverse, but the fact that you, right now, are aware that in all the immensity of the cosmos, in all the vast sweep of time, there is this moment of being, this flicker of consciousness, this thought. You are the miracle the universe has produced. You are the question it asks itself. You are the witness, the dreamer, the storyteller, and whether or not the cosmos lasts forever, whether or not time has an end, that fact can never be erased. So perhaps we do not need to fear the silence at the end of time. Perhaps we do not need to fear nothingness. Because the universe has already achieved something greater, it has become aware of itself through us. And in that awareness lies a kind of eternity, not the eternity of endless time, but the eternity of significance, the eternity of meaning, the eternity of wonder. And so the story closes, not with an answer, but with an invitation to marvel, to question, to live fully, to embrace the mystery. Because in the end, the greatest truth is not that the universe exists or that it will end, but that in the brief moment between beginning and end, there is awareness, there is life, there is you, and that is enough to make the cosmos more than matter, more than energy, more than space and time. That is enough to make it beautiful. That is enough to make it meaningful. That is enough to make it eternal. In the end, after wandering through the vastness of cosmic history, diving into the enigmas of dark matter and energy, peering into the paradoxes of time and the mind-bending role of consciousness, we return to the simplest, most haunting truth. Existence itself is a mystery. No matter how deep science digs, no matter how far telescopes reach, no matter how profound philosophy becomes, the ultimate question remains untouched at the core. Why is there something rather than nothing? Why are we here to ask at all? That question has echoed since the first human gazed at the stars and wondered, and it continues now, amplified by every discovery and deepened by every theory. What we've seen is that the universe is not static, not eternal in any simple sense. It had a beginning, or at least that's the story told by the Big Bang, when time and space themselves erupted from a singularity into the vast cosmos we know today, and it will have an ending, whether in heat death, collapse, rip, or decay. But in between beginning and end, in the thin slice of time where stars burn and planets circle and life arises, there is something extraordinary, awareness. That is where we live, in the middle of the cosmic story, between the fire of creation and the silence of the end. And in that middle space, fleeting though it is. Meaning does not come from permanence, because nothing in the cosmos is permanent. Stars die, galaxies dissolve, even laws may change. Meaning comes from presence, from the fact that in this fragile moment, we exist. We breathe, we think, we dream. The universe looks at itself through our eyes, asks questions through our minds, marvels at itself through our wonder. That is significance. That is beauty. That is truth. And yet, the mystery remains unresolved. Perhaps it always will. Perhaps reality is not meant to be solved like a puzzle, but lived like a story. Perhaps the point is not to reach a final answer, but to dwell in the wonder of the question. If so, then the cosmos has already achieved its greatest triumph. It has created beings who can ask, who can seek, who can marvel. We are not the center of the universe, but we are its voice, its witness, its storytellers. Without us, the stars would shine in silence. With us, they become more than fire. They become meaning. So the conclusion is not an ending, but an opening. It is an invitation to continue the journey, to keep asking, to keep wondering, to keep living in awe of the fact that there is something rather than nothing. The universe may be vast, fleeting, mysterious, and indifferent, but with consciousness, with awareness, with life, it becomes more than matter. It becomes experience. It becomes story. And as long as that story is told, as long as even one mind wonders why, the cosmos is not empty. It is alive. It is meaningful. And maybe that is the greatest revelation of all, that the answer is not beyond us, hidden in the farthest galaxy or deepest equation. The answer is here now in the very act of asking. We are the mystery and the meaning, the question and the answer, the spark and the silence, and that is enough to make existence, however brief, eternal.